So in this lesson, we're going to continue looking at inequalities, but we're going to look at what are called compound inequalities. There exists two types of compound inequalities. It's called an AND compound inequality or an OR compound inequality. Best way to understand the difference between the two is to take a look at them on a number line. So here I have a statement. Notice that the compound inequality involves more than one inequality. In fact, here it involves two separate inequalities. This statement right here is saying that x is greater than 3. Notice that the x is on the open side. You can read inequalities backwards. X is greater than 3. So here's what I'm going to do. I'm going to label some stuff on here. If I know I have to be greater than 3, let's put 3 right here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We'll call that good. Make this 2 and a 1. So it has to be greater than 3. So at 3, I'm going to put a circle. And let's see, x is greater than, so it goes to the right. And notice that it doesn't have the equal sign under it, so it's not going to be filled in. Great. But in this compound inequality, it also says that x is less than 11. So at 11, I'm going to do a circle, keep it open because there's no equal sign. Less than is to the left. Notice what happens. What the two arrows would have been doing, pointing to each other, ends up creating this region when you look at it all together. It creates this region of values that are greater than 3 and less than 11, which is what this statement up here is saying. Okay, we call this an AND compound inequality because the value of x has to both be greater than 3 and it has to be less than 11. Okay? Contrast this with the next statement we have right here. Let's read this from the middle where the x is. X, it's on the closed side, so it's x is less than or equal to negative 4. I'm going to put the negative 4 right here, negative 3, negative 2, negative 1, 0, 1, 2, 3. Put a few more on there for good measure. Notice what it's saying here. Again, x is less than or equal to negative 4. So at negative 4, I'm going to put a circle and fill it in because it's less than or equal to, and less than goes to the left. Again, the x is on the closed side of the inequality, so x is less than. But then if you look at the other piece of this compound inequality, it says x is greater than 2. Well, I'm going to go to the 2. Well, it's greater than or equal to, so I'm going to fill it in, and greater than is to the right. So to the right, I'm going to draw my arrow. This is a little bit different because of the directions that the arrows are pointing. You'll notice instead of pointing towards each other, they're pointing away from each other. And in other words, the solution to this inequality right here, x has to be less than negative 5, which is this region here, or, that's why we call it an or, it has to be greater than 2. That's this region over here. So again, this first one, the regions are combined, so it has to be greater than 3 and less than 11. Over here, it has to be less than negative 4 or greater than 2. Those are the differences between an AND and an OR when it comes to compound inequalities. So let's look at two examples of what we're more likely going to see in the context of compound inequalities. So I've got this statement, negative 12 is less than 2 times x minus 3, which is less than 16. The goal is to get x by itself, to solve for x. So what we would normally do is whatever we do to one side, we do to the other. Here, because I have 3 separate regions separated by the two inequalities, whatever I do to one part, I have to do to everything else as well. So here's how I'm going to do this. I'm going to distribute this 2. So negative 12 is less than 2x minus 6, which is less than 16. I'm now going to add 6, but whatever I do to this middle part, I have to do to all the other parts. So that becomes a negative 6 is less than 2x, which is less than 22. Okay, so I added 6 to each part. Now the last thing to get x by itself is to divide by 2. So whatever I do to one piece, I have to do to all the other pieces. Negative 6 over 2 is negative 3. It is less than x, which is less than 22 over 2, which is 11. Oh, 11. So this statement finally says, now that I've got an x by itself, that x is greater than negative 3, but less than 11. So I'm going to make a mark at negative 3, and then here's negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 9, 10, and 11. We'll go a little bit higher, 12, 13, and down to a negative 4 here. So the first statement is that x is greater than negative 3. So at negative 3, I'm going to put an open circle. Greater than is to the right. But then it also says x is less than 11. So again, open circle at 11, and I'm going to draw the arrow to the left. It looks like this is going to be an AND compound inequality because the arrows were pointing towards each other, which indicates that the only solutions are the values of x that are greater than negative 3 and less than 11. Anything out here and anything out here won't make this compound inequality true. If we want to satisfy both of the inequalities, the value of x must be between negative 3 and 11. So here's one more example to drill home this concept. I've got 6 is greater than or equal to negative 2 times x plus 2, which is greater than or equal to negative 10. So I'm first going to start doing my distribution. 6 is greater than or equal to, I believe that's going to be a negative 2x minus 4, which is greater than or equal to negative 10. Let's add that 4. That produces 10 is greater than or equal to negative 2x, which is greater than or equal to negative 6. Okay, last step to solve for x is to divide the negative 2 away. Again, I have to do that to all the sides. So 10 over negative 2 becomes negative 5. X is by itself, and then the negative 6 over negative 2 becomes a 3. But notice what we just did. We just divided everything by a negative. When there's inequalities, whenever we divide by negatives, we have to switch the direction of the signs. So now they're opening the other way. I've solved for x. Let's see what it says. It says that x is greater than or equal to negative 5, but it also says that x is less than or equal to 3. So I'm going to start down here at negative 6, negative 5, negative 4, negative 3, negative 2, 0, 1, 2, 3, 4, 5, 6. So x is greater than or equal to negative 5. That's this one here. Greater than is to the right. It also says x is less than or equal to 3. So I'm going to fill that in on the 3. And less than is to the left. So we'll notice that the arrows are pointing together again instead of apart, which means that this is an AND compound inequality. The solutions that satisfy this compound inequality here have to be between negative 5 and positive 3. So there's another example of a compound inequality. Key things to take away: that you could end up with one of two solutions, an AND or an OR solution, and also that whatever you do to one part, you have to do to all the other parts, because the multiple inequalities split it up into more than just two sides. In this case, there's 3 parts.